Okay, this is Arnold Chavez, the director of the museum, and he's going to go ahead and introduce our speaker for today.
Hello, everyone. This is Tom Crain. He is our speaker today. A little bit about Tom here. Got to know Tom here 2 years now, Tom, has it been?
About 2 years.
Tom got his master's from the University of San Francisco in marriage and family therapy. He's been with the museum as a volunteer for the last roughly 2 years. He's also a caregiver for our wonderful animal ambassadors, so the animals that you see in there, Tom helps keep them healthy.
I just fed them.
You just fed them today, yeah? Wednesday's his day. He is a NASA JPL ambassador, astronomy ambassador. He writes articles for our member emails as well as Facebook posts, so if you follow us on Facebook, please do. We're also just got on Instagram. Tom will write articles for that for us concerning astronomy. And something that, shame on me for not knowing this, today is Tom's birthday.
I'm 39. My name's Tom Crain, and I've been a docent here for a few years, and I'm a member of the NASA JPL Solar System Ambassador Program. I was selected to be a member in January of this year. And the idea of the program is to have members of the community who have an interest in astronomy to talk to the community about their experience and their understandings and their enthusiasm. And while I don't have hard science in my background, NASA doesn't require hard science for its volunteers. I would say, however, that I'm an amateur astronomer. The emphasis is on amateur. The very first computer I got it to run astronomy software. Back in the mid-'80s, I got a telescope. I tracked Halley's Comet. Got 40 sightings from December '85 to June of '86. I'm halfway through the Messier catalog of deep sky objects. My most memorable experience with the telescope was in the middle of the night, cold, by myself, and I saw the shadow of Io on the surface of Jupiter. You can Google Io and get all kinds of pictures to see the shadow, but I did this directly in real time, and it was really very memorable. And this is the sort of thing that NASA had in mind. For people like me to share my experiences, to share my understandings. And in this case, I want to talk to you today about this guy, Carl Sagan, a legendary astrophysicist from last century. Some of the preliminary stuff to get out of the way, his education, his employment, some of his professional awards. As you look at this, I just want to note, I stopped trying to list all the awards, page after page after page. These are just some of the big stuff. I also want to draw your attention to his dissertation. I'm going to be talking about that in a little bit. And I also want to draw your attention to his being a co-recipient of the Szilard Award. A whole bunch of people he worked with were co-recipients of this, and I'll talk about that later when I talk about his activism. And then this final line here, his gifts to mankind were infinite. I mean, obvious hyperbole, but nevertheless, it illustrates the extraordinary esteem in which Sagan was held by the scientific community at the time. These are some of the things I want to be talking about today. I will just simply make note, when we talk about NASA missions, I'm not going to be talking about the missions as such. I'm going to be talking about Sagan's involvement with the missions. Sometimes it was peripheral, secondary. Other times he was fully engaged with the instrumentation, with the science. And you'll see as I go which ones are which. And at the end, there's some other things I want to talk about, his activism and so on. So let's jump in to Mariner 2. I couldn't resist including the movie poster. 1958, Queen of Outer Space. Zsa Zsa Gabor was the Queen of Venus. I was in my early teens when I saw this movie, and it just didn't matter to me that the Queen of Venus spoke with a Hungarian accent. The point about this movie poster, though, is it just showed how ignorant we were about Venus. Some people thought that, well, since we're in such proximity to the sun, that at the equator we have tropical zones. It's warm, it's very pleasant. Venus is closer to the sun. Wow, maybe they have tropical paradise around the planet. And hence, Queen of Outer Space, Queen of Venus. But of course, that was just ignorance. And a young Carl Sagan, in his dissertation, talked about the known elevated concentration of CO2 in the atmosphere of Venus. And in his dissertation, he argued that this was a result of a runaway greenhouse effect. And he predicted that the surface of the planet would have an elevated temperature. Now, he was involved in the radiometer, the design and functioning of this instrument. And sure enough, this was the first flyby we had of any planet. Mariner 2 was the first NASA flyby. The data confirmed that the surface temperature at the time was 300 to 400 degrees. Of course, since then, with improved equipment, we now know that the surface is closer to 900 degrees Fahrenheit. And so much for the hot babes of Venus. Okay. In the 71 NASA Mariner 9 mission, this was our first orbital mission. And Sagan wasn't involved directly in the science or the instrumentation, but he and a colleague, James Pollack, had theorized that the recurrent observations made by Earth scientists of a wave of darkening across the surface of the planet was not evidence of a seasonal change, the way we see the change on Earth in the seasons, like now we're losing the leaves on the trees. It wasn't a change in vegetation. It wasn't a seasonal change. They argued, in fact, it was the result of global dust storms. And at the time of orbit insertion, the spacecraft cameras couldn't even see the planet's surface, because indeed, global dust storm, it lasted for weeks. And recently, if you follow the Martian rovers, they were covered with dust as well. So this was the Mariner 9 mission. And again, something that he predicted was correct. This is the 72 and 73 Pioneer 10 and 11 missions. Again, he had a kind of a peripheral involvement. He and Frank Drake and Sagan's second wife designed this plaque. And it's a gold plaque, 6 by 9 inch plaque. It was right here, attached to the support struts for the antenna. And it showed humankind next to the spacecraft, the solar system, hydrogen atom. And this, I'm going to talk about it later when it comes to Voyager. This is a map of pulsars whose singular frequencies converge on the solar system to tell an alien civilization, this is where we live. These are some pictures taken by the Pioneer spacecraft. The optics, of course, weren't as good then as they are now, but this blew the scientists away at that time. The Pioneer 10 photo of Jupiter in 74 and the Pioneer 11 photo of Saturn and Titan in 79. Now, both Pioneers are dead in the water. They're moving, but they don't transmit data. And Pioneer 10 is currently heading towards the star Aldebaran in the constellation Taurus. And Taurus is about right here. If you draw a line through the Earth and go that way, that's where Taurus is going to be. And the Pioneer 10 is heading that way at about 27,000 miles an hour, right there. And Pioneer 11 is heading towards the constellation Scutum, or the Shield. And Scutum is about right here in the sky. And that's where Pioneer 11 is heading at 25,000 miles an hour. They haven't left the solar system yet, as the Voyager spacecraft have, but they will. Okay. And this is the 75 NASA Viking 1 and 2 missions to Mars. And Sagan was fully engaged in these missions, involved in the design of the instruments. As you can see, standing next to the spacecraft. He was fully engaged, fully involved. There's 2 identical spacecraft. They landed 5,000 miles apart and conducted the same experiments. Dig in the soil, grab some stuff, bring it back into the spacecraft and analyze for microbes. And the consensus of the science was, there's no evidence of life here. It's interesting soil, but there's no life. The consensus was that Mars is a lifeless planet, and we haven't found any evidence to the contrary so far. The one spacecraft landed in the Golden Plane and the other at the Utopia Plane on Mars. Identical experiments, 5,000 miles apart, nothing. This must have been disappointing to Sagan. I mean, there's no doubt in my mind that he would have wanted to find life or evidence of life. But he was always about evidence, always. And he would say things like, the absence of evidence is not evidence of absence. He would also say things like, extraordinary claims require extraordinary evidence. And he would poke fun at people who claimed to have been abducted by an alien civilization and brought up into a spacecraft. He'd say things like, next time you get abducted and you're brought into the spacecraft, make a distraction. What's that over there? Grab an ashtray and put it in your pocket. He would say that. Yo.
Question, I don't know if you know the answer, but when they were digging up the soil samples, do you know they were going for different depths or?
I don't know.
Yeah, I'm curious.
I don't know.
Yeah,
there might have been no way of knowing depending on how dense the soil was. I don't know. It's a good question. Okay. This was the Voyager missions 1 and 2. In this case, he was involved peripherally again, but in an important way. Each of these spacecraft carry the 12-inch gold-plated phonograph record that tells a story about us. They include 118 photos, the 90 minutes of music from around the world, past and present, an audio essay of the sounds of Earth, greetings in 60 languages. Both of these spacecraft continue to transmit data. To this day, right now, they continue to transmit. It takes about 8+ hours for the data to get here, but they're sending the data. And the data tells us that these spacecraft have left the solar system. And how we know that is the instrumentation on board the spacecraft received pressure from the solar wind. Charged particles from the sun impact the instrument. At this time, the pressure of that impact is less than the pressure of the impact of charged particles from the interstellar space. There's greater pressure from interstellar space, less pressure from the solar system. They are out of here. I wanted to include this picture of Io that Voyager took. Io is probably my favorite moon in the solar system next to our own. It is the most volcanic body in the solar system. Just incredibly volcanic. And this picture shows volcanic activity. Later, you'll see even more. These are just pictures of the records. And again, here's the, I'll talk about this in a little bit, about how to find us. Voyager is heading towards the constellation Ophiuchus. And Ophiuchus is above Scutum. So if Scutum is around here, this is just very general, then Ophiuchus is going to be up here. So right now, Voyager 1 is heading towards Ophiuchus at 38,000 miles an hour. It's really moving. And Voyager 2 is heading towards the constellation Pavo, or the Peacock. It's a southern constellation we don't see in these northern latitudes. But Pavo is way down there, okay? If you draw a line through the Earth that away, that's where the Voyager 2 is heading at 34,000 miles an hour.
Oh, question?
Yes?
What happened to the couple?
What happened to the couple? They got divorced.
There was a big political yow-yow because
Yes, because of the naked.
was shorter and sort of
Yes, and the nakedness. Yeah, there was a lot of headache. Okay. About a year before launch, the Voyager project director, mission director, contacted Sagan and asked him, "Would you make this story? Would you and a team of people develop this story, which we're going to put on a phonograph and attach to the spacecraft? Would you do that?" And Sagan and a team of people did it, and to commemorate their efforts, in '78 they published Murmurs of Earth and a companion CD. And I want to play for you a couple of sounds that are on board the Voyager spacecraft, and a couple of pictures. But first, let's do some sound. This first one is a harmonic of planetary motion. Actually, it's a shout out to Johannes Kepler and his laws of planetary motion. There's a 30-second clip I'm going to play for you, and the higher pitch that you hear will be representing the planet Mercury. The lower pitch you hear will represent the planet Jupiter, and then in between. Also, there'll be a difference in frequencies. The inner planets revolve around the sun more quickly, so you'll hear a greater frequency. This is a 30-second clip, and it represents 100 years of planetary motion. Go Kepler. Real music of the spheres. I think Kepler would be pleased. This next clip is a piece of music that many of you will recognize, I think, and some of you may not, but I hope you enjoy it. Okay, the next slide has a couple of images that are on board the spacecraft. The first one, a picture of Earth. I think it was taken by one of the Apollo astronauts. Yes?
Was that Carl Sagan with Chuck Berry?
Yes.
Oh,
Yep.
okay.
Yep.
Very cool.
Yeah, that's super cool.
I think this was a picture of Earth taken by one of the Apollo astronauts. And Sagan named it the meadow in the middle of the sky. And the image on the right is, I call it the treasure map. And it involves the pulsars, the 14 pulsars whose unique singular frequencies converge on the solar system. And any intelligent alien civilization who captured the spacecraft and could successfully interpret the record could find us. And in fact, soon after Voyager 1 and 2 were launched, there was a skit on a comedy show called Saturday Night Live. And in the skit, hosted by Steve Martin, he played a character who claimed that indeed Voyager was captured by an alien civilization and they sent word back to us. And it was 4 words that were sent to us. And they were published on the front of Time magazine. And the 4 words sent back to Earth proving the existence of an alien civilization. Those 4 words are Steve Martin. They had fun with this. Okay, with this next slide, the 1989 Galileo mission to Jupiter, this was another example of Sagan being fully engaged, fully involved with the instrumentation, the functioning, data analysis, everything. This was supposed to be a 2-year study of Jupiter, 95 through 97. Curiously, right after launch, there was a serious issue regarding the long gain antenna. It didn't deploy properly. That was a serious issue. But the NASA engineers MacGyvered the thing and were able to use 2 short gain antenna to transmit the data. The data was stored on magnetic media on the spacecraft, and then it was sent in dribbles to Earth through those short gain antenna, and fully successful. No data lost, everything transmitted. This was such a successful mission that NASA extended it 3 times. The transit to Jupiter used what they called a Vega trajectory. Now, that simply means there was a flyby of Venus and 2 flybys of Earth to do gravity assist, the slingshot effect that could send the spacecraft to Jupiter. The spacecraft was launched from the shuttle. And the analysis, well, let me put it this way. The instrumentation on board the spacecraft wasn't designed to study Earth. It was a planetary probe designed to study a planet, anywhere, not just Earth. But with these flybys, the scientists decided what a perfect opportunity for a control experiment. Let's see what this modern planetary probe has to say about Earth. And it turns out Galileo made a strong case for life on Earth. Now, this is a real summary of the findings. If you're really curious about the science of it, there's a PDF file that you can get and you can read it. It's the science of it. I'm going to do just a quick, brief summary. There's an enormous amount of oxygen in our atmosphere. 20% of our atmosphere is oxygen. That's a lot. There's no other planet in the solar system with that. Where the heck does it come from? It doesn't come from underneath the Earth, coming up through the rocks. It's created. And the idea is, of course, it's created by life, photosynthesis. The instruments showed that there's a strong absorption of light at the red end of the visible spectrum on the planet's surface. And of course, think chlorophyll. Chlorophyll absorbs red and blue and reflects green. That's why plants are green. And that's more evidence of life generating oxygen, photosynthesis. A third finding was a surprising amount of methane in the atmosphere. Now, I'm not a chemist, but it's my understanding that the chemistry of methane in an oxygen environment is pretty simple. It dissipates immediately. Methane doesn't last in an oxygen environment. But here we've got all this methane. How is that possible? Well, the conclusion is that it's being injected into the atmosphere at a rate greater than the chemistry can dissipate it. And with his delicate way of putting things, Sagan said it's a bunch of bovine flatulence. Today, Neil deGrasse Tyson would say more directly, it's the burps and farts of domesticated livestock. Also bacterial action in bogs, cultivation of rice, a lot of methane. It's a greenhouse gas, and there's a lot of it in our atmosphere. And these 3 findings would have been the case going all the way back to life on Earth. But the last finding only would have been discovered in the last 150 years or so. Really organized radio transmissions. Think about listening to your car radio. there's evidence of a technologically advanced civilization on this planet. These are really organized radio transmissions. So at any rate, the instrumentation was successful. There is life here. Oh, I wanted to say a little bit about Europa. It's essentially an ice ball moon around Jupiter, but it has a liquid water interior. There's more liquid water in the interior of Europa than all the oceans on Earth. And wouldn't it be great to be able to get a sample of that and see what's going on there? And I wanted to also show you some of the more, the optics have so improved about Io. These are two pictures of Io taken a couple months apart, November of '99, February 2000, same location on the moon. Extraordinary volcanic activity. With this next slide, this is the Cassini mission to Saturn, and in particular to Titan. Titan just fascinated Sagan. There are a number of moons in the solar system that have atmospheres, thin, wispy atmospheres. Titan is the only moon in the solar system that has an atmosphere so dense, so thick, that you can't see the surface of the moon. And that fascinated Sagan. He and a colleague, Bishun and Kare, conducted some experiments at Cornell, and they identified the constituents of Titan's smog, the complex brew of hydrocarbons that create a dark tar-like sludge they call Titan tholin. Tholin is Greek for muddy, that rains down on the surface of the moon. And the Cassini spacecraft, which was launched in 1977, added confirming detail with the 2005 Cassini-Huygens landing probe. And it determined that there were dunes of Titan tholin and, more surprisingly, lakes of liquid methane.
So what was Titan? Titan was
A moon of Saturn.
a moon Saturn?
A moon of Saturn.
Oh, a moon of Saturn.
Yes, it orbits Saturn, one of Saturn's moons. And another moon of Saturn is Mimas, this one. And I guess you can well imagine the nickname given to this one. Indeed, the solar system has its own Death Star. And this is another interesting moon, another snowball, ice moon, Enceladus. It too has a liquid water interior. In this case, though, through the cracks in the surface, there are plumes of water vapor being emitted. And wouldn't it be great to have a flyby capturing this water vapor and seeing what the chemistry is there? Before I move to the next slide, I want to preface it with this. Of all the things that I've read about evolution, the passage I'm about to read from Carl Sagan just moves me. It really does. It speaks to me, and I hope it does for you. I'm going to read it, so bear with me. If we look at life on Earth, we find astonishing similarities. For example, we and the chimpanzees share 99.6% of our active genes, which means either that 0.4% is a larger number than we had hitherto understood, or that we have a lot to learn about ourselves from studying those guys. And the apparent gross differences between us and oak trees, slime molds, killer whales, viruses, I mean, that's a big range, right? And yet you look closely and you find all of those beings, all the beings on Earth, use nucleic acids to encode the heredity material. It's the language of life. They all use amino acids, the building blocks of proteins, as a catalyst that control the chemistry going on inside and in the vicinity of the organism, and use essentially the same code book to translate nucleic acid information into protein information. How could those impressive, formidable, awesome similarities occur unless all life on Earth has evolved from a single common ancestor? If that is true, and that is certainly the prevailing understanding, then we know almost nothing about life because we have only one example of it. All the differences are superficial. Down deep, there is only one kind of life on Earth. If there is life elsewhere, does it have nucleic acids? Does it have proteins? Does it have the same code book? Never mind if they look ugly. What are they based on? How do they work? Where do they come from? We don't know. I took a picture of the sculpture in the lobby and the plaque alongside. And the stairs, of course, have engravings of letters of a DNA sequence of insulin. And the sculpture is a DNA sequence of a stress hormone. And I figured the sculptor wanted to make reference to the finals. In this next slide, I wanted to draw your attention to the periodic table of elements. And of course, hydrogen, helium, and lithium were all created in the Big Bang. We got all of the hydrogen, helium, and lithium we have in the Big Bang. Everything else, all the other naturally occurring elements, are created in explosions, nova and supernova. Now, there are some elements that we created in our laboratories. Those aren't naturally occurring, it's homebrew. But all the others are naturally occurring, and they come from stellar explosions. So that the carbon, the nitrogen, the oxygen, the iron, the calcium that are in us all comes from the stars. And of course, this is a famous quote.
Some part of our being knows this is where we came from. We long to return. And we can. Because the cosmos is also within us. We're made of stars. We are a way for the cosmos to know itself.
The iron in our hemoglobin, in our blood, has the same atomic number as the iron in the girders that support this building. If we're genetically have kinship with the flora and fauna of Earth, then we have atomic kinship with the universe. In late 1973, Sagan made his first appearance on The Tonight Show with Johnny Carson. Carson was an amateur astronomer, and he provided Sagan with a national stage, a national audience. And this was the brass ring for Sagan. And he took hold and held on for 13 years and 26 guest appearances. Here was the scientific visionary who could popularize scientific ideas, astronomical concepts in ordinary everyday language, easily understood by the layperson. The American public ate him up. Sagan was the face and the voice of science and astronomy in the last decades of the 20th century. This clip is 40 plus years old, and it's as relevant today, in my opinion, as it was then.
But the thing that I find most striking is the enormous, remarkable capability of virtually every small child for learning. They start out eager, intellectually wide-eyed, asking extremely clever questions about the world. And then something happens, by and large, to discourage them. I think it's a tremendous waste of resources. For example, a kid asks, Mommy, why is the grass green? And very often you get an answer like, oh, don't ask dumb questions, or who knows. When in fact it's an extremely profound question. And how much better is it? In both those cases, it goes to the fundamentals. In one case of biology, in the other a kind of physics. How much better it would be to say to the child, that's a good question, Johnny. I don't know the answer. Maybe we can look it up. Or nobody knows. Maybe when you grow up, you'll be the person to find out. I think kids who are discouraged from asking those questions wind up learning the lesson that there's something bad by using the mind, and we lose resources, and we need those intellectual resources because we are in very perilous times. And I think the complex and subtle problems we face can only have complex and subtle solutions. And we need people able to think complex and subtle thoughts. And I believe a great many children have that capability if only they're encouraged.
In this next slide, talk a little bit about Sagan's activism. In this first image here, in the early 80s, there was some thought in Washington and the Pentagon that a nuclear war was winnable, that the United States could win a nuclear war. And a whole bunch of scientists, including Sagan, looked into this, and they found the concept they called nuclear winter, and they elucidated it in great detail. And he summarized their findings in this report to Parade magazine. And the reasoning is quite simple, straightforward. Not only is there the initial death and destruction associated with the fireballs of nuclear explosions, there would then occur numerous, intense urban firestorms, which would send ash and soot, smoke high into the atmosphere, blocking the sun, interfering with photosynthesis for a long time. So not only do we have the death and destruction of the initial fireballs and the deaths associated with lingering radiation, now we have cold, starvation. Yeah, there's no winning a nuclear war. It's lose-lose. The next image I want to reference is this one, the greenhouse effect. Again, with a number of other scientists, Sagan talked about his concern and worry about our dependence on fossil fuels. And of course, remember, Sagan knows a thing or two about greenhouse gases and the greenhouse effect, his dissertation on Venus. And he argued with the other scientists that we have to wean ourselves from the use of fossil fuels. It's bad news. All fossil fuels are hydrocarbons. And it doesn't matter who you voted for president. It doesn't matter what your political ideology is. When you combust hydrocarbons, certain things happen. First, you get energy in the form of heat, which is a good thing. That's what we've been using for thousands of years, to cook our food, to warm ourselves, and essentially, for better and for worse, to drive our civilization. But in addition to the energy of combustion, there are some other things. There's carbon dioxide, and in the case of inefficient combustion, carbon monoxide. And there's also some little bit of water vapor. Doesn't matter what your politics are, you combust hydrocarbons, you're going to get greenhouse gases. The more you combust, the more hydrocarbon you combust, the more are you going to get carbon dioxide in the atmosphere. And what carbon dioxide does, it creates a greenhouse effect, warms the planet. It doesn't go anywhere, it doesn't dissipate. It stays in the atmosphere or it goes into the oceans, which is what we're seeing now in terms of ocean acidification. The Earth is under no obligation to see to it that we survive. It's up to us. And where we're headed, there's some real doubt, huh? This next image, these two images, I wanted to have fun with his political activism in the 80s. At a time when Russia unilaterally discontinued underground nuclear testing, the United States continued nuclear testing. And Sagan, with a bunch of others, committed some misdemeanor beef, hopping a fence, and he was arrested twice. He was politically active. With this next image, at that time, excuse me, Ronald Reagan was president. And he developed what he wanted to call the Star Wars shield, the Strategic Defense Initiative, SDI. And Sagan unilaterally, just in a singular expression, blew it up. He made this extraordinary, original, if outrageous comparison. He likened the Star Wars shield to a leaky condom. So many warheads get through. Boom. And in this image here, it's the cover of a book by Lester Grinspoon, Marijuana Reconsidered. Grinspoon was a professor of psychiatry at Harvard University and essentially a lifelong friend of Sagan. Many of you may not know, maybe some of you do, Sagan was a huge fan of cannabis. He smoked weed from the early 60s for the rest of his life. He would smoke weed the way some people drink wine, daily. In this book, you can Google this, Google Marijuana Reconsidered and the essay by Mr. X that appears in this book. And of course, it turns out that Mr. X was Sagan. And in it, he spoke about the satisfaction, the pleasures of smoking weed. Smoke a joint and go have a nice dinner, enjoy it. Smoke a joint and listen to music, enjoy it. Smoke a joint and go to an art museum, enjoy it. Smoke a joint, go for a walk with a tape recorder, and think out loud. Later have it transcribed, read it, and then decide what you could elaborate upon, elucidate further, or simply discard as nonsense. He never publicly said that he smoked weed. He did come out in favor of medical marijuana publicly to help people deal with the side effects of treatment for cancer, but he didn't say he smoked weed publicly. I mean, this was a guy who was in front of Congress all the time. Professor Sagan, are you stoned? No. Okay. Okay. In this next slide, some of his legacy with regard to pop culture. His Dragons of Eden won the '78 Pulitzer Prize in General Fiction. In September of 1980, the series Cosmos hit the airwaves. Hundreds of millions of people around the world enjoyed this. 2 Emmys, a Peabody Award, and the companion book Cosmos, best-selling science book published in the English language. And in this book, Contact, and the corresponding film Contact, published in 1985 and posthumously released in '97, I think this was his way of representing what kind of an alien civilization he wishes there were that we could find out about. Extraordinarily technologically advanced and benign. That's the kind of vision I think he had for what he'd like to see. In this last image here, the reboot of Cosmos starring Neil deGrasse Tyson, who I think is Sagan's heir apparent, and Druyan, who is Sagan's widow. She is one of the producers, writers, and directors, and there will be new episodes next year. In some of the more serious science and research-oriented aspect of his legacy, in 1980, Sagan and a couple of JPL pals founded the Planetary Society, nonprofit, grassroots organization, pro-science, pro-space, pro-robotic spacecraft investigation, about 50,000 members currently, 100 countries around the world, and the current director, maybe someone you know, Bill Nye the Science Guy. In 1984, the SETI Institute was created here in California, and Sagan was on the board of trustees when he passed away. And then in 2006, at the SETI Institute, there came into being the Carl Sagan Center. And in 2015, there was another Carl Sagan Institute created at Cornell University, and Ann Druyan is on their board of directors. So we have East Coast Carl Sagan Institute, West Coast Carl Sagan Institute. Sometime back I contacted JPL to talk about copyright, and they talked about the Carl Sagan juggernaut. In this final image, the NASA Hubble Fellowship Program has 3 components, 3 categories: the Hubble, the Einstein, and the Sagan Fellows. And each of these categories addresses a separate question. The Hubble category addresses the question of how did we get here? The Einstein category addresses the question, how does the universe work? And the Sagan question is, are we alone? And the current Sagan Fellows are these guys. Each of these fellows, all of the fellows, they get about $70,000 a year for up to 3 years. This slide, there are a number of vignettes about the pale blue dot image, and at least 4 or 5 vignettes. And this is far and away the best I've ever seen. So enjoy. I think this is Carl Sagan at his best.
That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on the mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they can become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
A mote of dust suspended in a sunbeam. In 1994, Sagan was diagnosed with a rare bone marrow cancer, myelodysplasia. It's bad news, really debilitating. It's treatable, and he did receive 3 bone marrow transfusions from his sister Carrie. But in a weakened condition, he eventually succumbed to pneumonia. He didn't recover, and Sagan died December 20th, 1996. He was 62 years old. That concludes my presentation, and maybe I can answer any questions if you have them.